we're going to talk today about factoring to solve quadratic equations. We talked about quadratic equations last class. Quadratic equations are the shape that is created when you graph a function that has a highest exponent of 2. So this is what we call a quadratic function. This little U shape that I've just created is called a parabola. That is what we use to identify quadratic equations. So it sometimes will be opening up, sometimes it'll be opening down. But the main thing we're trying to find in the next couple of days is where it crosses the x-axis. That's pretty much our focus for the next couple of days. So last class period, we talked about how to solve quadratic equations, which are these little U-shapes called parabolas that I've just drawn on your page. What we talked about last class was how to identify the x-intercepts from a graph and from a square root method. So finding where the parabolas that are given cross the x-axis, which is what I just highlighted in yellow. So what we're going to do now is we're going to do a couple of questions to try to figure out, again, how to find our solutions to our given parabolas. So we've already talked about the first two types, graphing and square rooting. So today we're going to be talking about factoring. Factoring is what we've already been doing since chapter 7. The only difference now is we're now going to be setting it equal to 0, as you can see in this question here. So if you look at the first part of this problem, or of the page that I have given you, this first part already has all of the problems factored. If you scroll down, all of these problems are already factored, which is fine. So what we're going to do in a second is actually go through the factoring process, but we're going to solve the first equation on the first page. The problem says, what are the solutions to the equation 4a plus 12 times 5a minus 20 equal to 0. By having it equal to 0, you know that you're actually solving. That's what makes it an equation. By seeing the word solutions, you need to relate this to that fancy word x-intercept that we were talking about last class. The whole point of solving quadratic equations is to see where it crosses on the x-axis. Okay, so let's start this off by solving. The great part is when your problem is already factored, you are going to follow a special rule called the zero product property. And what this means is you're going to set each polynomial, in this case each binomial, equal to 0 and solve. So the zero product property means set each polynomial equal to 0 and solve. That's why the equations are equal to 0. Okay, so let's take that information, set them equal to 0, and solve. So I'll have 4a plus 12 equals 0, and 5a minus 20, not 12, 20 equals 0. That's all you're doing. So especially when your problem is already factored for you, set them equal to 0 and solve. I'm going to subtract 12 first. And then after I subtract 12, I'll divide both sides by 4. My first x-intercept that I found is negative 3. Let's do the same thing with 5a minus 20. I'm going to add 20 to each side. And then I'll divide both sides by 5. These answers are your two x-intercepts. So if you think about graphing this function that I just highlighted in yellow, where they would cross on the x-axis is at positive 4 and negative 3. We're going to do a few more questions, keeping that rule in mind that I just talked about. The zero product property is setting each polynomial equal to 0 and solving. Okay, so let's look at example 1. Example 1 looks a little different from the last question, but I will tell you that it's already factored. Okay, this is why I specifically put the word polynomial. A polynomial can be a monomial, which is one term, a binomial, which is 2 terms, or a trinomial, which is 3 terms. When you're solving a problem using the zero product property and factoring, a polynomial is mainly going to be a monomial, like we see in example 1, and a binomial, like we also see in example 1. So for this question, I'm going to set b equal to 0, and I'm going to set b plus 7 equal to 0. All this person did was probably factored out the GCF. I'm still following the rule that I just gave. Set each polynomial equal to 0 and solve. Okay, so b equals 0. That's technically already done. B equals 0 doesn't need to be solved any further. The 7, though, I need to subtract on each side. So b equals negative 7. This polynomial has two x-intercepts, 0 and negative 7. For example 2, same thing. We're going to use the zero product property to solve. So I'm going to set 8y equal to 0 and 2y minus 12 equal to 0. What I don't want to see you guys do here is distribute. If I was in class and having you guys answer this, you guys would probably tell me, oh, we got to distribute. That's just wasting time. If you're asked to solve by factoring, somebody has already factored it for you, so you don't have to worry about it. From here, I'm going to divide both sides by 8 to get me y equals 0. And then for the second one, I'm going to add 12. And I'm going to divide both sides by 2. So y is going to equal 6. All right, let's do probably a couple more, and then we'll move on for today. Okay, I don't think I want to do A on this page. These are all easy. Let's do some fun ones. Yes, numbers 7 through 9. Let's look at those. Okay, we already have our two polynomials, so our binomials in this case. There's two of them. So let's go ahead and solve. By using the zero product property, I'm going to set each polynomial equal to 0. Just like normal, we're going to solve. I'm going to divide both sides by 8. So t is going to equal negative 1/2. Okay, don't panic. If you think about this, on the x-axis, there is a space for negative 1/2. We don't use it very often, but it can have a fraction for your answer. So if you get to questions that look like this, don't panic. Keep solving. You have your answer. We're going to do the same thing with 3t plus 6. Again, this problem has two x-intercepts. The two x-intercepts are negative 2 and negative 1/2. Pause the video, and I want you guys to try questions 8, 10, and 12. So do questions 8, 10, and 12. Use the zero product property. Pause it now. When you were solving question 8, you should have gotten h equals positive 1/4 and h equals negative 1/2. It is okay to have two fractions for your answer. For question 10, you should have gotten s equals negative 6 and s equals positive 3/2. For question 12, you should have gotten g equals negative 1/3 and g equals positive 5/2. If you do not understand how I got the answers for these questions, pause the video and send me a message now. The first part of this was extremely simple. All we were doing was taking somebody's previously done work, which was already factored, and we were setting our equations or our binomials equal to 0 to solve, or our polynomials equal to 0 and solve. The reason why I kept saying polynomials for the zero product property is because I'm a jerk. I will give you guys questions that just have a b sitting outside and have you figure out what to do with it. If you don't know to set it equal to 0 and solve, you didn't pay attention to this video. Polynomial, again, from the zero product property that's underlined in black, means a monomial, binomial, or even a trinomial. Mainly for the purposes of this page, we're going to use monomials and binomials to set equal to 0. So, we've already done the fun part. Now we got to do the real work. Unfortunately, from here on, we're going to have to factor. I did make a few changes, which I'll show you in a second, but for right now, I'm going to read the little statement that's at the top of the page. If you rewrite a quadratic equation as the product of two factors, or of your factors, that equals 0, you can solve the equation. To solve equations in this manner, you must use your factoring skills. So remember that game that we played, the little murder mystery, last week or a couple days ago? That's going to be helpful now. So all the factoring review stuff we've been doing, whether it's some kind of game or around the room activity, this is going to help us. So for this question here, we're going to look at, again, what are the solutions? Your brain should be thinking, what are the x-intercepts for this equation? There is a major rule here that I need you guys to write out, and I'm going to highlight afterwards. These equations must equal 0. If you look back on the previous questions that we've done, don't worry, I'll wait. If you look back at the previous questions we've just done, for y equaling 0, all of the previous questions were equal to 0. All of these, that's why I said I'll wait. Look back through all of them. All of these equations are equal to 0. So in order for us to factor these adequately, all of these equations, including this one, must equal 0. Okay, so let's do the first thing, which makes the equation equal to 0, not 20. So in order to make this equal 0, I'll subtract 20. Okay, now that this is equal to 0, I'm going to use my factoring skills to solve. Okay, well my leading coefficient, or my a value in this case, is 1. My b value is -1, and c is -20. Okay, I'm going to make a little x based on my factoring skills, and I'm going to factor. I need two numbers that multiply to -20 and add up to -1. Don't worry, I'll wait. Let's use -5 and +4. If you multiply them, you'll get 20. If you add them, you'll get -1. The great thing is, since this a value is equal to a +1, I don't have to do that crazy grouping stuff where I have to find the GCF. I just get to write my answers as x minus 5 and x plus 4 equal to 0. Normally, if we were in class, I'd say, are we done? And this is when some of you guys would say yes, and some of you would say no. The whole point of doing this is to find your x-intercepts that we've underlined at the top. So I need to use the zero product property, so I'm going to put in red, the zero product property, ZPP, and I'm going to set x minus 5 equal to 0 and x plus 4 equal to 0. This is the last thing you have to do. So to find the x-intercepts, I'm going to isolate both x's. Your solutions, or x-intercepts, are +5 and -4. Those are your two x-intercepts. I'm going to scroll down, and I'm going to show you the changes that I made. Pause the video so you can make the changes on your paper. Trust me, you'll thank me. Pause the video and make your changes. So I'll eventually get to these questions here, but I want to start up here at the top, just to kind of ease us into the questions at the bottom. Okay, at the top of this page in purple, we'll do question 13 and 18. So we'll start off fairly simple. Okay, question 13, let me zoom in a bit. We're going to solve this by factoring. Okay, so to factor, I need to label a is 1, b is 3, c is 2. Okay, so let me make my little x. A times c is 2. B is +3. Okay, I need two numbers that multiply to 2 but add up to 3. Don't overthink it. Just use 1 and 2. From here, I'm going to factor. Since your a value is already a +1, I'm going to write my two binomials as y plus 1 and y plus 2 equal to 0. By putting it equal to 0, you're telling yourself, hey, you're not done. You still need to solve using the zero product property. So by using the zero product property, you're going to do y plus 1 equals 0 and y plus 2 equals 0. That means our first one, when you subtract 1, will be y equals -1. That's one x-intercept. And then I'll subtract 2 on each side. So y will equal -2. I want to make a quick disclaimer here. No matter what variable I use, so in this question 13, we use the variable y. In the next question, we're using the variable a. I don't care what variable it is. All of these are giving you the x-intercepts. So don't tell me, oh, Ms. Tapia, this one has 2 y-intercepts. It doesn't. It has 2 x-intercepts. These are not the y-intercepts. Let's look at question 18, and then we'll do some of the fun ones at the bottom. For question 18, first thing I'm going to do is label A, B, and C. Okay, off to the side, I'm going to make a little x, and I'm going to try to find 2 numbers that multiply to -30, but add up to 29. Again, especially for this question, don't overthink it. We can use 30 and 1. Unfortunately, 1 has to be negative, so let's make the 1 negative. If you were to multiply them, you'll get -30. If you were to add them, you would get +29. Ugh, gross. The a value isn't 1. So since the a value isn't 1, we have to rewrite the problem, replacing the 29 with 30 and 1, and then solving. So let's solve. And this is a -6, not a plus. So glad I double checked that. -6. Okay, let's factor by grouping. So if you don't remember, you're not using the zero product property just yet. You're factoring by grouping. We're going to group the first 2 terms and then the last 2 terms. And we're going to factor out the GCF from each. In the first group, we can factor out a 5p. That will leave in parentheses p plus 6. In grouping the second 2 terms, we're going to factor out a -1. I had told you guys, when you're factoring, whatever that sign is in front of p, or the variable, make sure you take that sign out. So -1, that will leave in parentheses p plus 6. Normally, we would write our answer as p plus 6 times 5p minus 1, and we would be done. But this is still equal to 0, which means I still need to solve. So in this space to the side, I'm going to take p plus 6, make it equal 0, 5p minus 1, and set that equal to 0. So I'm going to subtract 6 on each side. So one of the x-intercepts is -6. The other one, I'm going to add 1 to each side. And then I'll divide by 5. So p is going to equal 1/5. Those are our 2 x-intercepts for 15, or 18, excuse me. We've already done this before. I'm not trying to reteach you how to factor. We have already done this. So when you're solving questions that look like the bottom ones, which we're about to do, don't forget your basic factoring skills. Y'all took a quiz over it. Y'all have done the review activities. You know this. So make sure you don't forget it. Let's go ahead and look at the new questions that I added in. Well, these questions aren't fun. Okay. First thing I want to make sure I do is set this equal to 0. And let me actually cross this part out. Should have crossed that out. So if you think back to the first couple of pages at this part here, we said that you have to make these equal to 0, which is what we did. So we're going to do the same thing down here. So all of these questions need to equal 0. Luckily, the new questions 20 and 21, make sure you write these as the new ones, are already equal to 0. So I'm going to do the same thing for question 19, 22, and then you guys can do 23 and 25, or 24. Okay, so let's start with question 19. First thing I want to do is make this equal to 0. Okay, so in order to make this equal to 0, I'm going to have to add the 40. So s squared plus 8s equals -40. I'm going to add 40 to each side. So 2s squared plus 8. I don't know why I have a p there. S plus 40 equals 0. There we go. Okay, I'm going to have to factor this. Before I draw an x, something looks pretty nice on here. I have 2, 8, and 40. 2, 8, and 40. Are they each divisible by the same thing? Oh, I'm so glad you said that. Yes, they are each divisible by 2. So what I'm going to do is I'm going to factor out a 2, and I'm going to leave s squared plus 4s plus 20 in the parentheses, and I'm going to factor from here. Don't worry about the 2, leave it there. I'm going to bring it down to part of my answer, and then the s squared plus 20, I'm going to have to factor. Okay, let's see if Miss Tapia can squeeze this in. So I'm going to make this 20 on top and then 4 at the bottom. Ooh, let's see. I have 2 times 10. That won't work. Or yeah, 2 times 10. 5 times 4. Did Miss Tapia pick an ugly question to solve? She might have. Gross. Let me think. 1 times 20. Let me write these out. 1, 20, 2, 10, 4, and 5. Well, looks like this one can't be factored. Well, not anymore at least. So for this question here, s squared plus 4s plus 20 equals 0. There are no solutions that we can draw right now. For all we know, they might have a, They might have a an actual solution. They probably do, but we haven't talked about how to solve this. So for right now, I'm going to add a note to this that says this is unfactorable. I'll reiterate, just because this is unfactorable doesn't mean that it doesn't have a solution. What I might do on our next section of notes that we're going to solve, I'll probably solve this to show you guys if it does have a solution or not. For right now, though, we're going to assume that it doesn't. All right, let's go ahead and look at question 20. Well, we'll see. If I figure out later that I can factor this, then we'll see if then we'll factor it then. But since I can't figure it out now, we're not going to worry about it. Let's look at question 20. Question 20 looks like another gross question. Let me look at this very carefully. If I look at this problem, I have an ax squared term. I have the bx, the middle part, the middle portion, but I'm missing the constant at the end. Whenever your c is missing, so whenever the c is missing in this, we're going to factor out the GCF. If you're looking like, wait, what do you mean the GCF? Okay, we'll look at both terms. You have 2 x's in the first term and 1 x in the second term. That means you're going to factor out an x, which we'll leave in parentheses, x minus 5. If I'm not mistaken, that looks just like the question we did at the top of this page, on the very first page. Looks just like this. Whenever you have questions that don't have a constant at the very end, you're going to get an answer that looks something like this. One of the answers will probably be 0. The other one will probably be a number. So, let's solve. For question 20, I'm going to set the first x. Let me actually write this in red to be consistent. Using the zero product property, I'm going to set x equal to 0 and x minus 5 equal to 0. Okay, well, x equals 0 is one of the x-intercepts. And then the other one, I'm going to add 5. So x will equal 5. Question 21, I will have you guys do in just a second. I'm going to do one last question. Hopefully this isn't a gross one like question 20. And we're going to see, or 18, 19, whatever one that was. And we're going to see what answer we get. Okay, question 22. I have 4h squared minus 18h equals 10. Okay, good. Okay, from here, yeah, hopefully this works. We'll see. Okay, for this question, first thing I need to do is make this equal to 0. So I'm going to subtract 10 on each side. After I subtract 10, we're going to look at this. Just like the last question, this one looks very nice in the sense that I think I can factor out some kind of number from this. So if I look at 4, 18, and 10, those are all divisible by 2. So I'm going to factor out a 2 from this problem. I'm going to have 2 parentheses, 2h squared minus 9h minus 5 equals 0. Okay, well this 2 is going to have to go along for whatever ride we give it. and we're going to have to factor the information in your parentheses. If you are running out of space, pause the video now and move this to the back side of your page. Okay, so let's finish this up. If I was to solve this, I'm going to have my a value being 2, b is -9, and c is -5. So that means I'm going to have -10 on top, -9 on the bottom. Okay, I know this one. You can do it as -10 and +1. That will multiply to the top and add up to the bottom. Gross. Unfortunately, we don't have a nice pretty number where we can write out our, write out our two binomials just by looking at it. Unfortunately, because of this 2, we have to write out the grouping stuff. So 2h squared minus 10h plus 1h minus 5. I'm replacing the 9h with the 10 and the 1. All right, let's group. Okay, in the first two terms, I can factor out a 2h. That'll leave me with h minus 5. In the second group, my sign is positive, so I'm going to factor out a positive number. It has to be something. You can't just put 0. So we're going to factor out a 1, because 1 and 5 are the GCF between both of them. That's going to leave in parentheses h minus 5. So down here in green, we're going to write our two binomials that we just found. We found h minus 5 as one of the binomials, and 2h plus 1 as the other. And we're going to set that equal to 0. Okay, using the zero product property, we're going to solve. This is where some students start thinking, wait, what do I do with this 2? Let me ask you this. Does a 2 have a variable with it? No, it doesn't. So since a 2 doesn't have a variable with it, you don't have to solve it. It only goes when you're using the zero product property for polynomials. So anything with the variable in this case. So for this question, I'm going to add 5. This is one of your x-intercepts. And then I'll subtract 1. This is your other x-intercept. Whenever you have questions that look like this, especially ones like we just did that have a GCF, don't think that that's not what you're supposed to do. Leave the 2 where it is. It's not going to change your answer as far as where it crosses the x-axis. All you need to do is worry about the two binomials that you have. Okay, let's take a step back and let's look at a couple questions that I want you to try. Right now, I want you to try question 21, 23, and 24. Pause the video and unpause it when you're ready for your answers. I'll wait. Okay, let's see what you got. For question 21, this is very, very similar to question 20 in the sense that there's no constant in this question. So what you should have done was factored out the GCF. I was hoping there was a number we could factor out besides 1, but there's no other number besides 1 that I can factor out. So instead of putting a 1, we can just put a b. If you're like, but I really want to put a 1, okay, fine, put a 1. And then you can put 2b plus 7 in the parentheses. Based on the zero product property, we're going to take 1b, or just b, to set equal to 0. And we're going to take 2b plus 7 and set that equal to 0. By 1b equaling 0, that's the same as b equals 0. No 1. It means the same thing. And then for question 2, or the second x-intercept, you should have got -7 over 2. For questions 23 and 24, question 23, I'm just going to write your answers. S should have equaled 3. S should have also equaled 4 over 3. Those are your two x-intercepts. And then the last question, we'll make this v equals -5 over 2, and v equals 1/3. There is one last question I want to go through, and I don't think I made a space for it. I didn't. It's cool. So what I want you guys to do, let's get rid of question 15. So this is the last question I'm going to do, so follow along with me. cross out question 15, and instead of question 15, let's use this one. X squared minus 4 equals 0. That looks extremely similar to solving by the square root method on the last page. If you don't believe me, flip it back. Don't worry, I'll wait. Okay, well, this is very similar to solving using the square root method. Technically, I would want you to solve using the square root method. But remember, Miss Tapia is a jerk. If I ask you to solve this by factoring, I still want to see your work for factoring. So let's solve this one really quickly, and we'll be able to be dismissed. Your a value in front of x squared is 1. Remember, the b term is missing, and c is negative 4. Okay, so I'm going to make an x to factor it. Make a bigger x. I'm going to have negative 4 on top, 0 on the bottom. We talked about this. Whenever you're taking the square root of a number that's negative and you're trying to make it add up to 0, you're going to take the square root of the positive number, so square root of 4 is 2. You're going to have one negative and one positive. Since we're asked to factor and your a value is 1, we're going to make this x minus 2 and x plus 2 equal to 0. From here, I'm going to use the zero product property to solve x minus 2 equals 0 and x plus 2 equals 0. Again, if this was normal circumstances, I would just have you use the square root method because you'd be done by now. But if I'm a jerk, which I'm banking on, I will have you solve this using factoring. So make sure you're following the steps I'm doing. Your answers, you'll add 2 to get one of your x-intercepts of positive 2. And then you'll subtract 2. These are your 2 x-intercepts. For this function, we added in place of question 15. If you have any questions over any of the problems I've just done, send me a message now. Double check the hub to see if there's any other assignments and or assessments that you need to complete today. Again, if you have any questions over anything, see me in the questions channel.